Hello class, today is our first video. I'm going to record this video for homework number 1, and it is going to be initial or introduction for using Fluent for this subject, which is heat and mass transfer. So let's see what is homework number 1 is about. We are going to simulate a metal bar made of aluminum with this thermal conductivity, and the two ends of this metal bar is at different they are at different temperatures, 110, the other one 10. The length of this bar is 100 millimeter, and the cross section is a rectangle, it's 10 by 10 millimeter. And the homework says you need to find the temperature of this bar at these two parts. So the yellow dots are the area you must find the temperature. Okay, let's start with Fluent workbench. So ANSYS is a package including many softwares. One of those softwares is Fluent. We usually open Workbench to have access to that package. Our university is using 18.2 version. So if you want to do this homework at university, you can easily go to our engineering lab, and those computers, they all have this ANSYS 18.2. Or you can install your own ANSYS at home in your laptop or tablet. At this website, ansys.com, you are going to search for free student product. If you go down there, this is ANSYS student. You click here, and you can have this download button here to download the install button and install it. But if you are using this one, it is going to be 19.2 release, which is 1 year after the version we are using, so there are going to be like a minimal differences. It's not a big deal. If you find some differences, you can just Google it and find the equivalent procedures. Okay, so let's find our Fluent. If you check here inside the ANSYS systems, Fluent is here. Double click it. So we have this solution here. It starts with geometry and then mesh, setup, solution, and results. We always start with geometry, and one by one, after finishing geometry, we are going to go mesh, setup, and the rest. So let's start with geometry. If I right click here, you are going to see two options here. Space claim, which is the easier version for drawing different geometries. This is the new version ANSYS added, and this design modeler is the old version. If you are familiar with ANSYS or Fluent, the old ones used to use this one. So let's go with and use space claim, which is much easier and much more closer to the SolidWorks, which I'm sure you are all familiar with it. Here you can see it says starting space claim, and it's a red, so you need to wait to for space claim to open. So it's ready. Let me maximize it. The first step here, you need to select what is the your sketch plan. Which one? Do you want to use XY, YZ, or XZ? So you come here, select this one, and depends on your mouse or cursor's position, you can select one of them. I want to select, for example, XY. So click here. Now whatever I draw, it is going to be at XY axis. If you want to be perpendicular, you come here and select plan view. So now we are perpendicular to this sketch plan. Let me go back to our homework. It is rectangular, a bar with rectangular cross section, 10 by 10, and the length is 100 millimeter. So I'm going to select rectangle here, and 10 by 10. Done. This is 2D, so you want to extrude this area, this 100 millimeter, to have our bar. To extrude this area, you need to use this pool. Click over pool and click the middle button of the mouse to move a little bit, and I'm going to drag it. You can drag as much as you want, but I'm going to have 100 millimeters. So I write 100 millimeter and enter. So it's accurate, and this is exactly 100 millimeter. If you want to fit your geometry inside, for example, you draw it's like this. If you want to fit your geometry inside this page, you can press Z in your keyboard. Okay, so I draw our bar 10 by 10, and the length is 100 millimeter. Done. So let's close this geometry. And if it's done, you are going to see this green tick here. The next step is meshing it. The meaning of mesh is when you have a geometry, usually it's very difficult to solve whatever you are solving for all the points existed in that geometry. For example, here we have a long 100 millimeter bar, and we want to find temperature. So one solution would be find temperature, for example, for 100 and 1000 points over that geometry. Or we can say, let's simplify it. Let's divide that geometry to smaller version and solve those discrete selected area, and then use those. We call it like a control volume. So those control volume, it's like a smaller division of the geometry. So we use this mesh to create that smaller portions, which is much more feasible and computationally possible for us. So I'm going to right click here over mesh and generate mesh. This is the default mesh. As you can see, it's instead of having big chunk of geometry or metal here, now I have smaller portions, and for each portion I'm going to have a few numbers, and it's much easier and faster. Because for this simulation we're not looking for that much accuracy, I'm going to just accept this mesh quality. Later I'm going to teach you how to improve the mesh quality. The homework says left side and right side have different temperatures. To make sure we're not making any mistake, let's name these left side and right side. So I'm going to click over left surface. If you can select it, you need to come here and select face selection and right click over this face and select create name selections. It's not a big deal. We just want to make sure we have a name for that side. I'm going to name it left side. And for the other side, again, click over it, select that face, right click, create name selection, right side. Now I have two names which you can see here for left side and right side here. So later when I'm assigning temperature 110 and 10 degree for these two surfaces, it would be easier for me to find where are they. Okay, done. Let's close it. As you can see, here I don't have that green tick, so you need to right click and update it. Okay, now I have green tick here. Now it's time to go for the next step, setup. Okay, here it says what type of accuracy you have, what is the dimension, because we already draw 3D geometry, so it knows what is the dimension. So, and about the quality of and accuracy of the data, let's go with double precision. Processor options, you can say I have just one CPU core, use series, or like us, usually we have like several CPU cores. I'm selecting 4 CPU cores. So if it's like a heavy calculation, Fluent is going to use 4 CPU cores of my computer. If you had GPU, you can select those here. Okay. Now ANSYS is going to be active. Okay, this is our ANSYS Fluent. You need to wait a little bit to have all the geometries inside. Okay, it's ready. The first part is general. So we have this 3 part here, which we have several sections: setup, solution, and results. Inside setup, the first part is general. So the type of solution solver you want to have, and the type of again solution, you can have transient or steady state. Later we are going to talk about it. For now, just select what I'm selecting. It is going to be steady state, so we are not going to have any time variable, and the rest is okay. Let's go for the model. Double click over model, and you have a list of the different models here. Because we want to calculate temperature, you need to turn on energy. So double click over energy and check here to have energy equation active. Temperature is part of energy equation. For the material, we already said let's select aluminum. Aluminum for Fluent is a default material, but we need to make sure everything is correct and thermal conductivity is correct. So I double clicked over aluminum and it opened everything here. This is the density, specific heat, thermal conductivity is 202.4. If it's you have different type of material, you can select where is it? You can select from the database. We have for Fluent a lot of different materials. If you have your own material, you can create your own. So everything is correct here. We are happy with it. We just have solid here, so we don't care about the air part, which is the fluid. And cell zone, it's about what type of, because we had two materials here. Here, cell zone says which one is my calculation area. Is this is going to be solid or it is going to be fluid. So here you are going to say click this part for cell zone, and as you can see, as a default, Fluent selected fluid, but it is going to be solid. So we don't want to have fluid for that. And that solid is going to be aluminum. It's already there. If you add several solids there, you are going to have different types, and you need to select here. So we made sure our cell zone, which is this bar, is solid, and it is here. Done with cell zones. Now boundary conditions. Now you need to assign left side and right side temperature. Because I named the left side and right side, now I have those two names here, and it's very easy to assign those two temperatures. For left side, I double click here and it opens. I don't want to have heat flux. It says, the question says it's a constant temperature, so I select temperature. And it's Kelvin. I don't like Kelvin. Let's go and change units. Select here and come and select temperature. Where is it? Temperature. Go for centigrade. Now it's easier for me. 110 for left side. Okay. For right side, constant temperature, it should be 10 degree. Done. We don't need to change the others. For the solution method, this is the CFD method Fluent is going to use. You have some options here. I'm gradually going to explain what are these options. But for now, don't touch it. It's okay. Controls, again, later you are going to learn more about it. Let's initialize it. Everything is ready. Initializing means let's ask ANSYS to put some numbers inside these mesh and check it if everything is working or not. It's like a trying once to make sure those formula and equation inside this mesh is working. They're not creating 0 or infinity. Initialize it. And as you can see, hybrid initialization is done. We have two options. Later we are going to see which one is suitable for which condition. I just selected hybrid, and let's go and run calculation. For example, 100 would be enough. Calculate. Okay, calculation is finished because we had like a few mesh, and I'm going to close this. As you can see, we have green check here. Let's open results. Fluent automatically imports all the data from our calculation to this part. First, let's see what is the temperature counter inside this bar. So I'm going to select this counter icon here. The name is okay. I don't care about the name. Domain is going to be all domain. I'm happy. Location, I don't want to have just for the left side. It should be for whole bar. So I selected the solid part. The variable should be temperature. Apply. Now you can see what is the temperature. Left side is hotter, 383 Kelvin, and right side is blue, 283. If you're not sure what is the calculator, what is this temperature? 383 Kelvin minus 273 is 110 centigrade. And for 283 minus 273 and 10 degrees. So this side is 110 and the other side is 10 degree. The question, the homework says find temperature at these 2 points. But I'm going to find something else. So let's find temperature at the center here. So I'm going to come and click probe to read the temperature. Now I can put X, Y, and Z here. 0.5, 0.5, half. This is Z direction. As you can see, I put, it was 100 millimeter, so I put 50 millimeter here. Now enter, and it says temperature here is 333. Let me 333 minus 273, it's 60 degree. So temperature at the middle of this bar supposed to be 60 degrees.